Let me tell you a story. I was in school learning basic trigonometry. You know, cosine, sine, tangent, all that good stuff. But something piqued my interest. When solving basic trig, you use a calculator to find cosine x or cosine sine, whatever x is that you need to find. However, I didn't know how the calculator was getting these numbers. I mean, sine 1 in degrees is 0.01745, so it can't just be a simple algorithm. So what is it? So I did what any young mind should do and asked my teacher. I asked, how could I calculate sine or cosine without a calculator? I figured this had been discovered before calculators, and even if it wasn't, it would need to be programmed into the calculator. So what was the algorithm for sine or cosine? And what she told me was, I don't know. What? You're the teacher, you're the one who should know. At the time, I was upset, but I couldn't really do anything about it. And I just had to move on. I've now graduated high school, and now I know how to use Google. So here is how you can find sine and cosine by hand, and why you should really just use a calculator. Firstly, you have to understand that this method isn't exact, rather an approximation that is so close that it is considered correct. Sine and cosine and tangent are functions that are non-polynomial, so we're using a polynomial to mimic these functions, and we do this because polynomials are much easier to calculate. Using the Taylor series, we can determine up to a certain extent of accuracy a non-polynomial function given x. In short, you have a series of polynomial terms that approximate a non-polynomial around a certain number, usually 0. A series in math, by the way, is an infinite sum of terms. So sine, for example, is x equals x minus x cubed over 3x factorial plus x to the power of 5 over 5 factorial minus x to the power of 7 over 7 factorial plus, and so on. This continues infinitely. The more we add, the more accurate, but the more complicated. Cosine has its own series, which looks like this. Again, these are approximations, and they're really good, but how come sine and cosine have different algorithms? I thought the series would be its own thing, so how come they're different? Well, there is a default Taylor series. It's just that, well, let me walk you through it. Let's go through cosine as an example, and we start with the basic Taylor series, which looks like this. Now I know this looks complicated, but I'll walk you through it. First off, A is the point around which we are trying to approximate. Remember, we're getting close guesses, not exact answers. And since approximations of the functions around the point 0 is the simplest, that is what we will do here. So A equals 0. The F's are the derivatives of what it is we are trying to find. That's where we get the uniqueness for every function. The first derivative, the second derivative, and so on. For cosine, there's a pattern. Cosine becomes negative sine becomes negative cosine becomes sine, and sine becomes cosine. And when x equals a and a equals 0, the pattern is 1, 0, negative 1, 0, 1, and so on. This again repeats infinitely. So we can plug this all in, and what we get is a Taylor series which has the different derivatives and a plugged in, which simplified looks like what I showed you earlier. Whenever the derivative is 0, that term just ends up being 0 and is removed in the simplification. And that is the incredibly basic guide to the Taylor series. I hope you learned something and enjoyed. Bye-bye.